here we go. I have pre-taught the last two assignments, so I'm going to try and pre-teach this assignment. And I am going to go through the States of Matter Engage tab. You, however, are going to be completing for your assignment today the Explore tab. And right now what I want you to do is turn to the person next to you and tell them, do the Explore tab. Do not do the Engage tab. Do that now, right now. Turn, tell the person. Good. So you should have told the person next to you not to do the Engage tab, but to actually do the Explore tab. So if you do the Engage tab, I'm going to be disappointed. But I'm going to pre-teach you the Engage tab. What I want you to do right now is I want you to go to your notes. Remember, if you're taking Cornell notes, it's in the notes folder on Schoology. If you're taking notes anywhere else, I'm sure you know where they are. Go to your notes right now. Take 10 seconds, pause the video if you have to. Go to your notes. I gave you 10 seconds. So we are going to start to talk about the different states of matter and how they interrelate. And I'm going to try and not mess this up for the third time. You didn't get to see those other mess ups, but here we go. So in general, there are three states of matter. And I'm pretty sure you know about solids, liquids, and gases, right? This unit talks about what makes them the way that they are and how they change from one to the other, right? The easiest way to think about this is with water. Liquid water is water, but solid water is ice. You know how we get solid water, right? We put it in the freezer. We take temperature away. We lower the temperature. To turn that solid water back into liquid water, we add heat. We take it out of the freezer. We can put it in the microwave if we're crazy and want to microwave ice. That's a thing we can do. We can add heat, and that will turn into liquid water. If we put it on the stove, for instance, or over a fire, that liquid water will eventually turn into steam and evaporate away or boil away. This is how we change states in all matter. It is not just water that follows these rules. So, temperature is actually a form of energy called thermal energy. You are either adding energy to a substance or taking energy away from a substance. And that substance is going to react, right? You know, we have molecules or atoms, depending on what our substance is, inside every substance, right? Water is molecules, H2O. And if we put thermal energy into that H2O, each individual molecule inside of that is going to get more and more energy. So why is certain substances in a certain way at a certain temperature? Well, solids have very little energy in them. They're like me right now, sitting here very calmly, trying not to hurt his knee, talking to you about what solids are. They sit, they don't move, there's other things close to them, they just stay in one place. That's solids. That's why they don't move out of the way when you hit them, because they are stuck close together. Not a lot of energy. Liquids, on the other hand, have more energy. They actually, there are some interesting little things where it looks like the atoms are vibrating. When they have more and more energy, that is what they do. They shift around. They start to be able to flow, right? That is what makes it a liquid. It has more energy than a solid, and the little individual molecules can move around. They still are kind of touching each other, kind of moving, right? Almost minimal amount of energy, right? Not moving, not locked in place, but enough to move around. And a gas is something with so much energy that it can't sit still. It is you guys at recess. You are bouncing off the walls. You are running around. You're doing all those things that it's okay to do outside, but in general, gases have the most energy. And in general, that's also thermal energy. But not all substances follow the rules the way you might think, right? So there are objects that will go from, here's vocab, by the way, if you're taking your notes. There are objects that will go from solid to liquid, like volcanic rocks heated and turning into molten lava. That's melting. Ice cubes do that. Everything does that. Fog forming on a mirror after a hot shower is condensation, right? vapor to liquid, soup gradually reducing in volume as it's heated in a pot. We know heating in a pot is going to be evaporation. And liquid coconut oil turning to a solid. This is a version of freezing, right? From a liquid to a solid. But there are two words up here that I almost never use. And I didn't even know one of them until recently. Deposition. Deposition literally means turning from a gas to a solid. And there are things that do this, apparently. Water vapor turning to crystals on a glass window in the winter is an example of deposition. Frost is resultant from deposition. I have lived 31 years without using that word, but you ought to have it. Deposition. Sublimation is a word that I've loved since I was in high school chemistry. It is what dry ice does. It is going from a solid directly to a liquid. It is irregular. Things don't generally do that, but it happens. Right? So then we are asked to sort things into their state. And you will have an opportunity to do this later in our lab, believe it or not. You're going to have to tell me what state of matter something is in. So we know that snow is a solid, molten lava is a liquid, helium gas inside a balloon is a gas, a glue stick, I'm going to go with is a solid. Melting wax, I think, is a liquid, and steam inside a sauna is a gas. Let's see if I'm right. Hey! So, we know that all matter contains energy, and different energies are what gives the different states of matter their characteristics. And we know that solid ice is going to have the least energy. And we know that liquid water is going to be moderate amount of energy, a middle amount, and water turning into a gas is going to have the most energy. And it's weird to me that they put them there in order, but they did. So, consider this, right? We have all this vocab, we have all these ideas, but essentially, what I want you to take away from this is what makes the differences in the different states of matter, and what effects that has on things. Well, the different states of matter are caused by the different amounts of energies in each individual molecule or atom within a substance, right? More energy generally equals further apart atoms, which equals more like gas, right? And gases that get hotter will actually get more and more energy, which if you think about it, makes a lot of sense because there are gases out there that don't burn you, like the steam out of your shower, as opposed to the steam from a kettle that you're using to make tea, right? Different gas can have different amounts of energy in it, but there are points at which they transition. And that's what I want you to focus on. Think about temperature as energy and consider why different states of matter have different characteristics. Sorry, I keep looking down. My cats are going nuts. You know what? This is Pete. He has been very annoying, but you get to see him in real life. So, good luck. I will be back tomorrow. Make sure you do the engage tabs. Not the engage tabs. Sorry, the explore tabs. Do the explore tabs. Don't do the engage tabs. Explore tabs. All right. Thank you.